Welcome to the Slack Chat podcast. This is a podcast to do with Slackware Linux and in particular Slackware ARM, because I'm Stuart Winter and I'm the developer and architect of the Slackware ARM port. And not with me today is Phil, because he can't get onto Skype and his mic doesn't work. But who we do have is Brent Earl. Hello, Brent.
Hello.
Brent's a guest today because he uses Slackware ARM and he also stepped up to maintain the Qemu scripts and things around the support for Qemu in Slackware ARM. So thanks for doing that, Brent. And we're here today to kind of fix it because Qemu got upgraded. Yeah, it was updated, wasn't it?
Yeah, up to 4.2.
Right. And I don't know what the previous version was that I was using, but the way I'd made the scripts doesn't work with the latest version because I think they changed the way the network driver support works or something like that. I can't remember.
Yeah.
Before we get into doing that, because that is quite a bit of it's kind of like a commentator, you know, the football commentators or the Formula One commentators, and they sort of like commentate on what's going on. It's going to be like, yeah, it's typing on the screen. I'm not sure. What about you? I mean, how did you get into Slackware?
I used to only run Debian around for like 10, 15 years, and then I switched to Slackware during the System D debacle.
Oh, right.
And I've been using Slackware since.
You actually came from Slackware you came to Slackware because of that. I actually thought people wouldn't do that. You did that.
It was a big learning curve, but it was actually better to use Slackware because it reminded me of how Debian was when I first started using it. So.
Oh, right. So how long have you been using Linux then?
Probably since like 1999 or so, but I didn't have an installation that I used like as a daily driver until about 2002.
I was kind of the same, actually. I installed it. I think it was, oh no, I didn't. I got a friend to install in 96. He installed Red Hat, but it was on like a spare PC that I was given. And then I kept on using my Acorn ARM machine with Riscos. And then eventually, once I got used to it, I switched over, got X working, all that stuff. I then eventually switched over to it, but it was like a transition path. I think everybody probably kind of does that to a degree, don't you?
Yeah. And well, the reason why I got into Linux is because I wanted to run a web server. So, I was learning how to code and make websites and stuff, and as I'm sure many people did back then. And I wanted something secure that would not need to be rebooted all the time.
Yeah, I mean, it's always been pretty stable, hasn't it? Most of the time. Yeah. I mean, I did as well. I ran everything: IRC servers, FTP, DNS, mail, else web, Squid, or proxy.
Yeah, is it working now?
Oh, hello.
Hi, Stuart.
Yeah, I can hear you. We started, Phil.
Hi, Brent.
Hello.
Now I should introduce Phil. This is Phil, and Phil maintains the Raspberry Pi support for Slackware ARM. And I forgot what we were talking about. Oh, Linux. Yeah, that's right. Sorry. I swear I haven't even got through an eighth of this beer that I have in my hand. It's been a long day. Yeah, but I mean, it's always been a really stable operating system. I mean, even whichever operating system you pick, as long as the kernel's, it's pretty much the kernel really, and a few some stuff. That's the main thing. Brent was just saying that he moved to Slackware only a couple of years ago because of System D. So there's an actual Slackware convert due to System D, which I didn't think I'd ever talk to anyone that actually did that. But
cool.
It's a first. But actually, I don't really want to go down the System D route, but I have not looked at another Linux distribution now. It must be over 7 years. I haven't touched another. I mean, apart from servers at work and stuff and shell accounts on different things, but not actually run one. I mean, what's the big deal really with System D? I mean, why did it cause you to desert your long-standing Debian distribution?
I didn't want to have to learn how to use it. It was like, as they introduced it, it was very confusing. The documentation sucked, and it was just too much to learn with what was going on, work and stuff. So it was just too complicated to learn, and I didn't have to use it. So I switched to Slackware.
So how have you found learning Slackware then?
It's difficult to compare them because there's a lot of differences, but I like mostly Slackware because it's very easy to control what goes on in the system.
Yeah. Do you have that kind of feeling of control over what it actually does?
Yeah, I mean, if you can pick as much as you want and learn as much as you want or as little as you want and still get things done. So
That's the same here. I can't imagine using if Patrick or when eventually Patrick stops doing it. And I'm not saying he is. I'm just saying like people do age and things. I don't know what I would do. It has occurred to me from time to time. I thought years ago I would have switched to FreeBSD or something because I'm not really too into other Linux distributions. I find them quite irritating. But I'm not sure what I'd do now. Maybe we should use my Mac. No, it's not mine. Okay, so QEMU, I'll give you a little bit of background about why it's there in the distribution, in case anyone's actually interested. I don't know. But the reason why QEMU is in there is because and actually this is going to turn into one of those stories, the Shaggy Dog stories. This is one of my bugbears about ARM. And one of the reasons why I kept telling Phil to stop asking about computers like ARM devices that just exist that you can buy. Well, didn't I? Well, anyway, if not, I've told many other people, is that if you go and you look at some ARM devices and people used to ask me, they'd email me and say, why, can you add support for this? Or why isn't this supported or whatever? And the answer is, have you looked at, is there upstream kernel support for a start? Does it support the network? Does it support the disk? Does it support this? Does it support that? And like, no. I'm like, well, it's not going in then. Because what happens is, even back in 1993, you'd have these. In my case, it was a Castle Ionics, which is a strong. No, it wasn't. It was an Intel X scale. So Intel actually bought ARM rights at some point or something like that. So Intel actually made an ARM processor, the X scale, and that's what was in there. And one of my friends had ported it to Debian well, he hadn't ported Debian to ARM, but he'd ported it to the Ionics, and he'd actually really ported it. He'd actually built, like he'd edited the Linux loader, he'd edited made lots of drivers and stuff and things like that and got it working. And so he'd done that for Debian, and then and he helped me get the Slackware stuff working. And so he gave me all of his stuff to make Debian work, and I made it make Slackware work instead, because this was like one of the machines in the journey, and the previous one was an old Acorn RISC PC. But what happened eventually, I'd spent like £1,000 on this machine, which is a lot of money, and then as Linux the kernel progressed, because all the support that he'd done, and it had never gone upstream, and it wasn't just to do with him, but there was a few other things. It hadn't gone upstream, so basically this machine was deserted. It was like abandoned, marooned, I should say, from the kernel. So basically at that point I was like, this is a lot of money to be wasted and a lot of time to get this stuff working. So I learned my lesson big time, is that unless the system, the ARM device, has support in the kernel.org mainline kernel, I'm not interested in it. Yeah. Or the developers can commit to having it for sure be in there pretty soon, and some of it's already in there. Other than that, don't touch it with a barge pole. It's one of the reasons why the Raspberry Pi, I never touched it. It's still not in there, is it? There's some Raspberry Pi stuff in the kernel, but I don't think all of it's in there. But that was one of the reasons why. And anyway, so what happened was I couldn't use that computer anymore, but I still needed to carry on with Slackware ARM. So I actually got QEMU, and then got my friend Jim Hawkins to patch QEMU so you could build GCC inside of QEMU. And then that got upstream. He was good at doing that. So that was that. And so that's why I was using QEMU for about a year or something like that, until I got the Kirkwood, whatever that was called, the Shiva plug on the Kirkwood processor, and then left QEMU. And then QEMU worked for a bit, but eventually I stopped using it, so I stopped maintaining the scripts and stuff. But it no longer works properly. At least it doesn't for you, Brent. It does for me. So I'm going to show you what I've got, and somehow.
Are you going to use the current scripts, or are you going to use 14.2?
Current. I'm not going to.
Okay.
Yeah. Are we going to find out you've only tested 14.2? That might be why it doesn't work.
Well, no. I've tested current only.
Oh, good. Because I'm not going to be doing anything with 14.2. Will be end of life once 15 is released. So I'm not doing anything with that. Right. Let's share the screen. See how this goes. Seriously, I was saying to Brent, Phil, before you came on, that I'm switching between lots of different communication tools like Skype, WebEx, and I keep now I'm just looking for the screen share. I found it in Teams earlier. Oh, here it is. And Skype, everything's in a different place.
It's like one box in front of another.
Yeah. QEMU is it's an emulator, so it's going to be emulating the ARM platform. of which there are many versions of the ARM platform. I'm not going to get into that, but QEMU emulates ARM, but it emulates a number of different ARM boards, all types of ARM, essentially system on chip kind of things. If you don't know what that means, go and look it up. But basically, it's an emulator. It's going to be emulating an ARM CPU. Really, the idea of QEMU in ARM, in Slackware ARM at the moment, is a hangover from when I used to use it. And then I was going to abandon it. Well, I did. And then Brent came along and picked it up. So why did you want to do that? I assumed you were using it, but I'm not so sure now.
Well, I was going to use it to build kernel packages for the Raspberry Pi.
Really?
Yeah, but then I abandoned that and I'm using Linux containers instead.
Okay. What device were you going to build kernels with?
I was going to use the Raspberry Pi 3 at the time. Now I'm doing it for the 4. I've been having trouble getting the Raspberry Pi 4 working. Like, there's lots of stuff that has to be changed.
Right.
You've got a Raspberry Pi 4, haven't you, Phil?
I certainly have. Yeah. Why I'm asking, Brent, is I build kernels predominantly. That's what I use the Raspberry Pi for. And I build kernels on every single one of them except the 0. And I'm a complete QEMU noob. I've never used it. When Stuart's mentioned it in the past, it's completely over my head. This is a brand new world for me. So it's interesting. It's always interesting to see what other Slackware users are doing with the software. But sorry, I'm waffling. My main point is, why would you use, and this is a novice question, why would you use QEMU to build a kernel on the device that you're intending to run the kernel on?
Well, Slackware doesn't come with App Farmer support, so I build that in. And there's a few other things that I add that make it fit my use case, basically. Mm-hmm. But lately I've been doing it for the Raspberry Pi 4 on SoftFloat because there's no kernel available on your site. And
right.
I have my Pi 4 running Slackware ARM 14.2 with the 5450 kernel. I use the Raspberry Pi firmware and then I built the kernel on top of it and replaced it. So
when I initially build a kernel for the Raspberry Pi, I use the def config, which are you building your kernel on the command line, or have you built some scripts to do it for you? Do you do it manually?
No, I just do it manually. I do it manually.
Okay. Yeah, I've done that. I've done that in the past many times. When I first build a kernel, when I went from the Raspberry Pi 3 to the Raspberry Pi 4, I actually built. It's a really funny story. You won't be interested in it, but I built the kernel for the Raspberry Pi 4 on a Raspberry Pi 3. And I used the default config just as it was straight off the bat, and it worked. It actually worked. I didn't actually have a video cable, so I couldn't see what I was doing. I know it's incredible and slightly unbelievable, but between the point that it crashed, or the point that I guessed it crashed, and the LED flashes of the activity green LED, I was able to work out where I was going wrong. So I actually got it booting into Slackware ARM, having built the kernel on a Raspberry Pi 3 and having no video cable.
You have to do stuff like, yeah, we talked about that, didn't I, before? Yeah. And I've done the same kind of thing. I'd be tailing varlog messages or syslog or whatever it is on my DHCP server to see whether the machine had booted up far enough to see if it got a DHCP address or an IP via DHCP.
Yeah. Plus, it has no serial header, so I couldn't log into it anyway. You know, if it had been an Orange Pi or a Hummingbird, I could have just plugged the serial connection in and gone from telnetted into it and gone from there. But it was interesting. It was slightly easier than I thought it would be, and I got there in the end. You know, it's quite amazing how you can build these kernels, and even though it was meant for the Raspberry Pi 4, you've just got to make sure that the firmware is in place. And usually you'll find most of the problems with booting, even if you've made a complete mess of the kernel, it'll still boot, or it'll panic, or do whatever's causing it to go wrong. It will still boot as long as the firmware is in place.
Yeah, I had to steal the Wi-Fi drivers from Slackware from your package basically. I copied it off from another SD card and put it on.
I think they need updating. I haven't updated them in quite a few months, so I'm going to get round to looking at those shortly.
Yeah.
Right. You know what? I'm really glad you guys have been talking, because it's the entire time that you've been talking, that's how long it's actually taken the installer to boot in QEMU.
Yeah.
That's kind of why do you use QEMU? It's not. I haven't done anything to slow it down, I promise you. Once you start using the machine, it's okay actually, but the boot up process is pretty damn slow.
It looks quick. It looks responsive.
Yeah, it's all right. I mean, it's okay. It does take a long time to install, though. That has to be said.
Yeah, so it takes a really, really long time to install it.
Yeah, and the machine it's on is not the fastest. It's on QEMU on my side is running on a. What is it actually? Oh no, the machine's pretty fast actually. I upgraded it a while ago. Yeah, it's running on a pretty fast x86-64 Slackware 14.2 machine. It doesn't make any real difference to how fast the QEMU is. But so the way that you boot QEMU, at least the way I've got it set up, that's the way that the way it's supported is that there's two scripts. Well, there's a few, but there's two main scripts. One of them is to launch the Slackware installer inside of QEMU. The other is to boot the operating system that you just installed. So there's two different scripts there. The scripts are somewhere on the FTP site. They're linked from the Slackware ARM QEMU documentation. As you can see, it's booted, right? So Brent, do you manage to get the installer working?
I get it to load the RAM disk, and then it panics because I can't find dev RAM.
So this is the script I've got. Brent, if you look, it should be the same as the one that's on the FTP site. So I have actually changed the script since we exchanged emails quite a while ago now, actually.
Yeah, I just tried booting, it still panicked. I noticed that I've had to rename it, the one that I've been getting, so maybe I'm just using the wrong RAM disk.
Even if you are, it should just boot the operating system RAM disk instead of the installer one.
Mm-hmm.
You need to
check. I'm refreshing all my scripts real quick. Kernels, there we go. So I want the init RD ARM v7, right?
Well, yeah, you want both of them really, because one's for the installer and the other one is the operating system. So yeah, Slackware ARM is slightly different. Well, it's different to how it's done in x86 in that because you have to support so many different ARM boards, you need lots of different modules for the USB and all that sort of different stuff. Right. So I provide an init RD that supports all the machines I support, rather than trying to, basically, so I don't have an enormous monolithic kernel, but the init RDs then load all of the required modules for the machines I support. So I have, unless you want to recompile, you want to change something in a kernel, you don't actually need to create an init RD, you just use the one that I ship. And in the case of QEMU, the init RDs are out, they're actually, they reside outside of the operating system, so they just live in the directory in which I keep the QEMU boot scripts and stuff.
Yeah, I literally just used the same exact script that you had, so I'm guessing I had the wrong RAM disk. I feel like we've talked about this before, but on the forums.
So if it doesn't work, you can actually start that script as I did there by, I don't know if you saw what I did actually, but I was just logging the output of QEMU. Yeah. Mm-hmm. I was interested in particular in this. Here, where is it here? I assume you can see I've highlighted that. Uh-huh. Yeah, so that's what I was interested. What you should be interested in if it doesn't boot with the latest stuff. Yeah. Just to see what you've got. I mean, it should be that. But
right, dev RAM.
Although you said already that it can't find dev RAM, so that would to me mean that you have got the right kernel command line setting. That's going to work well on the podcast. We're all looking at a screen. The QEMU boot scripts, it's present working directory, so I've got the scripts in the same directory as these two that you see highlighted, which is the init RD and the kernel. So you can see them here. There they are, look. So I've highlighted the initRD and as the installer. So I just keep them in that directory there. Doesn't matter which directory.
Well, what I was asking was, here, I'm gonna put it in chat. I'm looking, this is where all the files are that I need to download, correct?
Right, yeah. So if you look in Slackware ARM-current/ISO Linux, then you'll grab them from there. For the installer, you do need the kernels from that directory, but you also need the initRD ARMv7 from the ISO Linux directory. But for the operating system, you do need the initRD from the kernels directory. So yeah, you got it right.
I think I probably knew that a while back, but it's been so long that since I looked at it, I forgot.
I was saying to Brent, Phil, before you joined, that I've barely done any development on Slackware since the pandemic started. I just haven't really done anything apart from maintaining it. All my development time, and it's funny how much, if you don't do something for long enough, and in this case it's not really that long, I really just do forget some of the stuff, kind of. I never used to be like that when I was younger though, but now I'm kind of getting rustier quicker, I think.
The old grey matter is wearing out.
Completely explains why it wasn't working.
Well, good. I'm glad it works, because there is a change though. So I can't remember what I changed. I started reading the oh, I did. Did I actually document it? My God, how good is that?
It's working like that. So before we were using the SD flag to boot it. So
yeah, and so this is one of my lovely professional habits of just documenting the changes, and I've actually put a little change log at the top of the script to remind myself of what I actually did, even though when I wrote it I thought I'll never read that, but actually I have. I've actually found a use for it. So I've changed, I don't know if I changed the machine type to this vExpress A9. I don't know what it used to be before, but I think it doesn't really matter.
No, that's what it used to be.
Okay. So I've changed this from an SD card to this virtual media, which means that the documentation on the website, I think it's just a website now, isn't it? That needs to change because this is oh heck, I've forgotten did I actually close QEMU? No, it's open. Come on, chop. That's right. So it needs to change from SDA to VDA in the documentation, but that's it. Oh yeah, the other thing I basically decided to remove all of the complexities like the bridge support, so and just use NAT, because I started reading the QEMU documentation and I thought to myself, this is going to be one of those massive slogs where you just sit down and really try to understand what it's actually talking about, because it was referencing things that I don't really understand, and I thought I'm not going to sit and spend hours reading and testing this, so I just simplified it.
You can remove all that from the documentation if you want on the wiki.
Yeah, it doesn't. If someone wants to do it, they can figure it out for themselves. I mean, I figured it out years ago, and I'm not going to do it again. It just doesn't. It doesn't make sense to do that. If anyone wants to use QEMU to play around with Slackware ARM, they can just use the NAT version. It's easier. And it also means you don't need this turn interface, I think, and some other stuff. You don't. It just reduces the complexity to use NAT. And unless you particularly want your QEMU machine to have its own IP address and run services on it, then you don't. But realistically, I can't imagine anyone actually wanting to do that.
No.
So I think NAT is the best thing. I mean, I wouldn't exactly suggest using QEMU for that much, because even though it's very nice as an emulator, it is slow. So you're not going to get. I mean, it's not going to. If you wanted to play with Slackware ARM, this is not really the way to do it, because because it's basically Slackware x86. You can't really tell the difference. But apart from it's going to be really pretty slow. So I mean, it is kind of responsive, but.
Well, I'm gonna keep maintaining it because it works, but I don't really need it anymore either. So.
Well, when you get bored maintaining it and it stops working, I'll probably dump it unless someone else wants to take it over. But, I mean, to be fair, it hasn't taken too long to fix it up. I was thinking
it doesn't take that long.
No, I was thinking it wouldn't do. So that's good. Yeah, but if you can just change the documentation on the site, that'd be really appreciated.
All right.
Simplify that thing. We were talking before about, I think before we started the podcast, that this what happens to Phil and I as well. We're having these conversations, then we realised we hadn't started recording it. So loads of stuff that could have gone in the podcast isn't in there. Yeah, we were talking before, Brent, about the Orange Pi, and that you wanted to use it for a firewall, didn't you, at home?
Yeah.
But is the Orange Pi, was it R1 you said?
Yeah, the R1. It comes with the Wi-Fi module and 2 Ethernet ports, so it's pretty good. The main drawback is because it's supposed to be used like a router, it only has 256 megabytes of RAM, I think. So.
Oh.
Yeah.
Isn't it the most basic model?
No, not really.
Just looking so I'm looking at the website to see. It says a quad core 87, so it should be. Yeah, that should be.
It's just a memory issue. So if you manually install it, it's fine.
It'd be an excellent device actually for using as a Linux firewall.
That's what Brent wants to use it for.
With the two Ethernet ports. Not gigabit, but I don't suppose that's going to matter much.
No, not if you're going to use it the way I'm going to use it.
Yeah.
That's why I got it. I was like, that's going to be quite useful.
Yeah. I have an Orange Pi with the H3 sock on it, and I really like it. I really do like it. It's a very innovative device. It's good fun.
So I got a prompt with the installer for Qemu. So
okay, it works.
Documentation,
Brilliant.
Oh, good stuff. I'm just going to have a look in the kernel config to see whether the H2 sock is actually supported. Because the Orange Pi I've got is an all-winner H3, so that's the Orange Pi plus 2E. I
think mine's just the plus. I think mine's the same. It's the same family, but the one before yours.
I had it working with Debian, Debian.
Mm-hmm.
But I wanted to try it with Slackware because, again, systemd.
I'm almost tempted, but not quite almost. Tempted to download and install a Linux distribution that uses systemd just to see what all the fuss is about.
Oh, Stuart.
But I'm not sure I really want to do that.
You don't.
If you want a world of pain, then do it. Seriously, do it.
Not sure I want to now.
for people who understand Slackware, or even for people who don't understand Slackware, the init system is by far less complicated and easier to work with than systemd. I mean, in my opinion, systemd, I hate to say this, but it works too much like Windows. It's a horrible, convoluted way of working, whereas you've got your run levels, which a lot of people understand what the run levels are and what they do, whereas I don't understand systemd. I can't work it out. I really don't know where I'm going with it.
Well, I gave it a shot, but on CentOS because I figured I needed to try it on a more enterprise environment, and it's very, I don't know. There's a lot of stuff that's unnecessary.
Yeah. I can't remember what I was doing something on FatDog on one of the servers, and God, what was it now? I had to build a script so it would run in systemd. Oh, I remember what it was. We run a Minecraft server, and that used to run on a Slackware server, and I used to use crontab, and every 3 minutes it would check to see if the Minecraft server was running, and if it wasn't, it would restart the script and it would run the server. But about 5 or 6 years ago, maybe 7 years ago, we switched over to Debian. And of course, it worked the same until systemd came in, and then I had to fiddle about with systemd to get it to do what crontab did so easily, and it just didn't work. And I spent hours trying to get it to work, and it wouldn't work. So from my limited experience and knowledge on systemd, it's not as easy or manageable as the init system. So I'm definitely not a fan.
Doesn't look like it has support.
No, I'm not sure. I wonder if that's because it is actually a 64-bit machine. No, it's not. It's 32-bit. Okay.
Yeah,
I thought it would be 32. Yeah. I thought I'd just check.
Yeah.
Okay. So what I'm just looking in the kernel looking at the kernel config for the Slackware current.
Yeah.
See what's in it, and it does not. Oh, then again, it also doesn't have the H3 listed here. So, boy. I'm starting to wonder if my beer is affecting my memory. But it seems like so long ago. It is funny. Like, they just don't do this sort of in-depth development anymore. Well, not anymore, but for quite a few months. And
it's the Sun 8i which supports the H3.
That's why. Yeah. So So this is what this one should be. Should be Sun. Right. Yeah. So the Orange Pi. God. Yeah. I was looking for the. I used to know all that stuff off the top of my head. I was kind of going that way, thinking it's got to be one of those. Sun 8i. Yeah. Okay. So the question is, what does that actually support? Oh, great. That's not very helpful, is it? Well, the thing is, unless it's so what I do then is just go and see whether it's supported by the Allwinner team. There it is, the Linux Sun XI website. That's what tells you.
I'm looking at that now.
Okay, yeah, it should have a big table somewhere, or one of them does. Shows you what the Allwinner support's like.
It supports the H2 Plus, H3, H8, and H80, but the H80 I think is not in production.
Well, maybe it's an H2. I mean, the only thing that's actually listed here is H2 Plus. So maybe this is the Orange Pi R1 is actually an H. Oh God, it actually says it. I only saw H2 somewhere further down here. I didn't realize it had a plus. Yeah, so it's supported by the kernel already. Right. It's already in here.
Yeah.
So the only thing that you'll need to do, at least I think so, the only thing you should need to do is, and who knew that the kernel didn't support the gold linker? I'm building Thunderbird. I use the gold linker for Thunderbirds for the memory to work around them, or to work with the memory constraints. It turns out the kernel doesn't support using the gold linker. What was I looking at? Oh yeah, so you need to know so basically, you need to then select the right DTB, the device tree binary blob. Oh, there you go. There's an R1 right there. Yeah. So you've got the DTB. You can actually use the kernel directly from there.
Yeah, that's amazing.
Already supported.
So I didn't even know. And there it is.
Because I remember it was a couple of years ago I got this thing, and it was saying you were saying on the forums that it didn't have support for the installer, but I never checked the hardware because it doesn't have enough memory for the installer.
Well, I've got to let you into a secret. I actually don't know if that's true because.
Well, I'll try it.
Yeah, I mean, it might be. The reason why, the reason why that I say the installer needs a certain amount of RAM is because the machine that I tested it on, the machine I was building Slackware ARM on at the time only had half a gig of RAM. And so I couldn't possibly know whether it worked anymore on machines that had less than it. So I said, that's what you need as the minimum. It doesn't mean it's actually true. It's just because I hadn't tested it. But on the other hand, the installer is quite large. It's getting larger and larger as we add more and more modules and whatnot to it, and libraries and stuff. And you can easily test it by just checking just changing the amount of RAM. Let's put 256 or whatever it was. Is that how much you had?
Yeah.
And then we just wait another
3 hours.
Exactly. Well, yeah. See what happens there. Oh, Brent was saying as well that he likes the fact that I don't push out the updates to Slackware ARM as often because it means you've got less work to do. So that sounds good. I was saying because I don't push the updates out as much anymore because even though I'm still building it, it's easier for me to do the testing once a month than pretty much once a month than it is to do it like 20 times.
Absolutely. That's one reason why I've slowed down on releasing SAPI updates because otherwise it's just too much work.
Yeah, exactly. And it's unnecessary. Well, it's also partly because Patrick merged PAM in as well. So I wanted to give it a bit of a break because I expected a bit of churn from that kind of stuff. But
there hasn't been much actually.
Nope. No, I mean, it had a lot of testing. But no, I expected there to be a few bits of breakage, and there really wasn't any. So brilliant job getting that working.
Yeah.
But yeah, I usually do that if there's any major change. I just keep out of it for a bit. Otherwise, I have to go and rebuild a whole load of stuff. It's easier not to.
I remember
it seems to be booting relatively similar to what I had when I had 1 gig. So.
Yeah, the amount of RAM isn't going to make a difference to how fast it boots. I mean, that's just the emulation.
Yeah, but it's not running out of memory. That's what I'm saying.
Yeah. No. I mean, to be honest, it could make this boot a lot faster, actually, if you wanted to. But one of the reasons why it takes so long is because it's loading. The initial RAM disk is loading lots and lots and lots of modules for hardware that isn't present.
Right.
Like this stuff is not on here.
Yeah.
It's not supported by this device, but because it's a generic installer and a generic initRD for the operating system, it loads a load of stuff that's not necessarily, most likely isn't actually physically present.
It's still trying to detect it.
Yeah, exactly.
Yeah.
Exactly. So it takes a while.
Right.
And, that's why.
Right.
On an real ARM machine, you don't really notice it. It's done in the blink of an eye, but not on here.
Yeah.
It is actually that slow. Well, I mean, the installer itself will work. I mean, because that's just a bunch of shell scripts, so that will work. It's just a case of whether the big thing is, will it install? It should actually, no, it should do. It'll probably just go into swap as long as you've got enough. Well, it will go into swap for sure as it's unpacking, I think. But I'm not sure how. Actually. No, I don't think it will actually, because basically it probably works fine. It'll probably install just fine. I might just leave it actually, just installing it. Yeah, I've already said, because I mean, all the TAR's really is doing is just unpacking stuff. Shouldn't run out of RAM just unpacking something. I mean, it's not like, I've run plenty of Unix machines where they've had gigabytes of TAR archives with half a gig of RAM. It's not like it runs out of RAM just unpacking stuff to the file system. So it should be fine.
What was it at? 40 megabytes? Is that what it said?
What?
The RAM usage.
That was the main concern.
That's what my router sits at all the time, between 35 and 40 megabytes with SRPI on it.
Oh, okay. Oh, I know. I was also concerned about the amount of RAM. Oh, that's why. I was concerned about the amount of RAM that the installer occupies in the RAM disk, and if there was enough left over. But I think it'll be fine, actually. I hadn't really thought it through. I just hadn't tested it and assumed it might not work. But the Slackware installer itself is just a bunch of scripts and running a few tools, which aren't RAM heavy. So, yeah, I guess it'll work. Let me know. I'll install it in 256 meg of RAM and leave it running.
Yeah.
See how that goes.
Well, I haven't done it in a long time, but I had 14.1 on my really ancient Asus Triple E PC.
On your what PC?
It's an Asus Triple E PC.
Oh man.
You remember those?
That's masochism, surely.
That has 256 megabytes of RAM.
Yeah.
But I haven't tried 14.2 on it since I don't know. Haven't used it.
Might be okay. It might be all right, but the machine itself is hampered by the hardware.
Yeah, it has a Celeron processor.
Yeah.
So now Slackware ARM is installing inside of Qemu.
Bro, this is like this reminds me of Docker. Where you create a container and work within the container. Oh yeah. And if that sounds stupid, then it's because I don't know absolutely anything about QEMU. Nothing. I know it's an emulator of sorts, but I've never used it, and I'm just glad that with Brent using the SAPI stuff, I'm glad it's nothing I've done that caused this problem.
No. It's just that every time they update a new point release of Qemu, they change something, and then you got to figure it out.
Yeah. That's one of the beauties of Slackware. When you've got to fix it, you really sometimes have to dig deep to get to the root of the problem, and then it's an education in doing so. So, you learn a hell of a lot more using Slackware than you would just installing a package on Debian or Raspbian.
Yeah.
Yeah, I've got.
So you run a Mac?
Mac here, yeah. There's a machine you're looking at. Yeah, it's a Mac. My actual machine I use to develop Slackware is actually an x86-64 Slackware 14.2 machine. And I have my one of my Orange Pi is also plugged into the KVM, so I can do the desktop testing and stuff. But yeah, this is my work machine for my job, and that's it. It also has Skype on it, so that's what I'm using here. Mind you, I still use the terminal quite a bit, although, well, because it's mostly web browsing and stuff.
It's so slow.
It wouldn't make a good introduction to installing Slackware, would it?
No.
Come back next week, you know.
Yeah, but it's QEMU, so
yeah. It's just QEMU. It's just slow.
Yeah,
that's all.
It's because of the processor that's being emulated is not very quick.
Yeah, I was starting. So that was interesting actually, because I was looking at. I wasn't sure if that's really the case, because I'm not sure if QEMU tries to emulate the number of like the actual megahertz of the thing. I think it might try to stay true to that. I've got a feeling it does, but I looked at some of the other, because I was looking. I think that QEMU has this option to just emulate ARM, but just be a virtual machine, not try to pretend to be something that someone designed years ago. And so you would just use, it just go as fast as it possibly could, but it's got a less built-in deliberate restrictions just because it was emulating a piece of hardware. But I think I started looking at stuff like that, but I couldn't get it working, or I couldn't get the network support working with it or something like that. So I just left it as the VExpress. That said, if anybody does know how to make QEMU, like make it faster by just not, emulating a different board, let us know on the forum, because it would be quite useful sometimes, particularly because the only machine that I've got, not the only one, but this one, which is the Orange Pi 2 plus 2E, which is what you see on the screen, which has got the 2 gig of RAM. That's the build machines that this is. My ARM build machines have a maximum of 2 gig of RAM, so building things like Firefox and Rust and other things would be kind of easier on a machine that had more. And QEMU can have like up to 4 gig of RAM for 32-bit, so that would be actually quite useful if it could make it faster. But it's not practical. It's not practical because it's just so slow to install and stuff. So
yeah,
can't be doing that.
Can I ask another stupid question?
As long as you promise that I can answer it with a really stupid answer.
Yeah. What is the purpose or application for QEMU?
For whom? For me?
For us?
Generally. Is it to emulate different architecture under, like a different, say you were running an A72 and you wanted to build for an A53, or
I don't know. I think, well, QEMU also emulates x86 as well. Yeah. So I think it's that.
What, on ARM architecture?
This QEMU that's running here is running on x86, emulating ARM. So I assume maybe you could. I've never actually tried to run QEMU on an ARM machine and emulate x86. I mean, you might be able to do that.
It doesn't work very well.
I'm really sorry, guys. That is just right. The light bulb is now on. Right, I'm with it.
So yeah, it's an actual emulator. So
right.
It's emulating the machine. But I don't know it's different from Docker because Docker doesn't emulate.
Yeah, exactly. It, to me, it looks similar, but it isn't. It does a completely different thing for a totally different reason.
Yeah. Yeah. So I mean, you think of it like VirtualBox or.
And that's something I don't do. I build natively because I've had so many bad experiences with cross compiling. So yeah, if I was on an x86 system and I had no other choice than to use an emulator, then that's what QEMU is for.
Yeah.
Yeah.
Well, you could use it for that. Yeah. You could.
Yeah.
You could certainly. I mean, I did. I ran out. Slackware ARM was built on this for.
You can actually build all possible emulated binaries for Qemu.
Mm-hmm.
If you just, I don't know, you can do that too. And you'll see there's like tons of available machines you can test.
Right. Yeah. The scope of it is quite impressive. I can imagine hundreds of applications for this.
Yeah, it's pretty useful. Yeah.
Good for testing live CDs, live DVD, or like Alien Bob's live disc.
Yeah. If I wasn't building natively, then I might actually find this useful.
No, you wouldn't really, because QEMU is you're basic this now is native. This is an ARM machine, so inside of here now, so it is native. So it's basically
you're running it on x86 architecture.
Yeah, but the kernel is an ARM kernel. It's booting the standard Slackware ARM. So this, as far as Slackware ARM concerned, is running on an ARM machine. It doesn't know it's QEMU. So this is native.
It's emulated.
Yeah, but it's native. As long as actually, that's one of the things. One of the issues I did have with QEMU a while back was that I was compiling stuff and things like NFS would just cause a kernel panic or something like that. And I wasn't sure if I was distributing stuff that was broken because QEMU was somehow broken it. But then when I put it on real ARM hardware, there was never a problem. So there was some problem with the emulation. But to be fair, I did build Slackware ARM on it for about a year, and no one complained, and everything worked. Yeah. So some things don't work properly, or they didn't. But usually they tend to be pretty good at fixing things. So it's a maintained and developed bit of software. So
it certainly beats cross compiling.
Yeah, well, certainly in my experience it did. I mean, I did originally cross-compile Slackware ARM, so there's still the stuff lingering on the website, or loitering. with no, it's not, because it's got no intent. It's intent to die. But there's all the old scripts are still there, or some of them anyway. But yeah, the problem with cross-compiling is that, well, there's a few different things, but one of them is that, well, I don't know if this still is the case anymore, but it used to be that the software, the majority of it, did not know that it didn't understand cross compiling, so that it wouldn't find the tool chain, or it would call on one, and then the worst part was when it would try to run the make install routine, or just part of the build process, would try to run the binary it just created in order to create some binary blob for part of the package, like some data file. Of course, you can't do that, so that would be, well, there is a way around that actually, but you can use QEMU to prop it up. But no, that's just a mess.
It's a world of pain.
Yeah,
it's a world of pain I don't need.
No, and then you also you make all the hacks. All of my old scripts were just lots of hacks to make things work. But then the problem is with that is you have to maintain the hacks. So when they change it upstream, you've got to then change the hack, and that could be really, really complicated and really, really time consuming. And it's easier just to build it on a much slower piece of hardware and just be done with it and do something else with your life. Quite frankly.
Absolutely, yeah.
Life is too short to be doing stuff like that anymore.
I just tested in Qemu 4.2 doesn't build on Slackware 14.2. It needs a newer version of some library, glib or something.
Yeah, I found actually I've had on my 14.2 the way I actually build now, the Slackware ARM build rig is like this machine you saw here, which is like the lead build machine. It has access to distcc on the rest of the machines on my network, which are all x86 64 Slackware machines, or Slackware 14.2 machines. So it has access to all of those cores, and then it runs the cross compiler. So on the FTP site you'll find there's what I've called x-toolchain. So I've got basically the Slackware toolchain, but a cross-compiled version of it, or an ARM. It's a cross-compiler version of the toolchain outputs ARM code for ARM targets. So it builds natively. All the linking and everything is done natively, but the compiling is outsourced to the x86 machines that run the same versions of the toolchain in Slackware Current. But every time say GCC changes on Slackware Current, for example, I had to upgrade Python and some other bits to get the latest version of GCC to build. So my 14.2 machines have suddenly got bits of extra, newer packages from Current on a 14.2 machine to start propping it up. So I'm not sure how much longer that's going to last, because that I don't like doing things like that. It tends to destabilize things, but it hasn't been a problem so far. The QEMU is working again. It's been on my list for absolutely ages, was to fix that.
I'll make some notes and something on my computer to remember that. It needs to be the other RAM disk and the ISO Linux vectors.
Yeah. I should probably change well, I'm not going to do it actually. But I was thinking I should probably do it, but no, that's just too much work. Because it shouldn't really be called ISO Linux, because it's not an ISO Linux. It's just that ISO Linux is the software for the x86, to boot the so that you put on CDs and stuff. Right, that's what it is. ISO Linux. So it has this bit of, so it's like Lilo, but you put it on CDs. But because the installer is always in there in Slackware x86, and I couldn't think of another name to use it, I thought I'll just put it in ISO Linux directory as well, even though it's not actually an ISO. You can't put it on one. So that is just a bit of a hangover from.
You can't change that, Stuart.
It's too much. I can't. Why would it break your script still?
No, if you change the ISO Linux path, then I have to start rewriting my sappy build scripts.
Oh, right.
Because it's the UNIT-RD ARM v7 image that I download from your source.
Oh, right.
I use that to build the installer.
The UNIT? Oh, you mean the UNIT-RD one?
No, UNIT.
What'd you get that for? These are the same, right? This is the U. It just means that it's been U-bootified, so you can boot it from the really old versions of U-boot that don't support.
Yeah, that's the one. That's the one that I use. That's the one I've always used.
Oh, okay. It's the same as this one. They're exactly the same, apart from it's got the U-boot header on it or whatever it's got.
I think in times gone by, I can't really remember why I used the UNIT-RD, but there's something to do with unpacking it. If I remember, I'm going back years now, but I had a problem unpacking the UNIT-RD, and the UNIT-RD just worked. Or was it something to do with the rebuilding of it? I'm not sure. I didn't make any notes of it, so I'm guessing.
Have I actually lost the plot? I'm trying to unpack this. Do you know what?
I've lost the plot because I've deleted some of my notes, and I distinctly remember in these notes it said, if you're using UNIT-RD, you must unpack it this way because Stuart says so, or something like that. And I've rewritten the scripts and not included those notes.
Oh, okay. Oh, well, anyway, yeah, the UNIT-RD is this one here. So, yeah, I was thinking I've lost the plot. I couldn't get it to do, what was it doing? I was just confused. Man, I can't believe I got to this. Do you know what, though? This proves to me one of the reasons why I still maintain Slackware ARM is because if I didn't, I would lose all my technical skills. Because, I mean, like, I haven't worked on this so much for about 3 or 4, what was it, since February? I don't even know now. What is it, 3 or 4 months or something? And I just had a brain fart and just didn't know what I was doing. And like, imagine if I'd done that for years, I wouldn't know anything anymore. Anyway, all I do is admin. It seems a bit of technical consultancy and lots of account admin and talking to people. But yeah. So anyway, there you go. Yeah. So you can Zcat that and then pipe it into CPIO-DI, and then I don't know I can't remember how you unpack the UNIT-RD off the top of my head.
Yeah, it was. I used to use DD.
Right.
It was DD input file blah 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 gzip and then CPIO. That's how I used to do it. And the new way is I'm digging out old scripts which have got cobwebs on here. The new way is different. Why is it different?
Oh, there you go. Yeah, that's how I did it. DD there, and then you.
Yeah, that's basically the same.
Yeah, that's
I think I got that off you initially when we were discussing how to unpack and repack it. Do you remember that conversation?
Yeah.
Maybe.
You
that's what I'm thinking.
You posted on LQ and you said something like, right, you do this, and you end up with this. And I'm like, but I'm a noob. What commands do I need? How do I do this? And you kindly explained it to me. So
I don't know how this is going to turn out on the podcast when no one can see what we're looking at, but we're looking at some scripts in the kernel source directory that unpack the initial RAM disk that's been modified for U-boot. Yeah, actually, I did consider removing the UNIT-RDs. Actually, that is on my to-do list, is to remove the UNIT-RDs. Oh, but I can't. Do you know, I spent ages reverse engineering some other Linux distribution, like some other Linux distributions build method to make U-boot build for the trim slice, which is one of the devices that I have that I still support because I own it and it still works. And I couldn't figure out how to get U-boot to build, despite being able to build it for all of the other ones. I just couldn't get it to work. I don't know why. It was incredibly complicated. Oh, I know why. Because it's something to do with the you have to pack the U-boot image in a particular way to make it work on the trim slice, and I just couldn't figure it out. So I reverse engineered some other Linux distributions make files, figured it out, got it working. That took ages, and I was so excited. Like, yeah, I can get rid of these unit IDs and tidy it up a bit, and because now I can have the new version of U-boot on trim slice, and it will just load the normal init ID or the standard gzip compressed version. And U-boot worked, it booted, and it would not find the network interface. And I was like, I don't think that the people that did the support for the trim slice, maybe they didn't put it in there or they broke it or something. I don't know. And I was like, wow. So that just didn't really go anywhere. So long story short, I'm keeping the unit ID until my trim slice breaks, so that I'll throw it away. So you'll have to change your script, Phil. Sorry, eventually. I'll let you know if I ever do that.
It won't be too much trouble. It's just a URL. I have like a settings file which I load when it's building. So I just change one line of the settings file, and it just loads a new, and loads new settings, whatever I want to set it at.
So, Brent, how are you finding the Slackware community? Do you use the Linux questions forum quite a bit? Or do you look
every once in a while I get on there and answer a bunch of questions and help people, and everyone's really friendly and knowledgeable, and it's a lot more refreshing than other distribution forums right now.
Oh, is it?
Yeah, they don't really, there's a lot of users, but they're not as technical, so they don't really give you the right information sometimes. I've never had that problem with Slackware, so usually it's read the docs and then come back.
RTFM.
That's what you're supposed to do, isn't it?
Yeah.
You have to be careful. Phil and I don't think we've actually recorded this on the podcast before, but we have talked about it. There are some people on there that sound very convincing, yet what they say is wrong. It's 100% wrong. And yet they have, on Linux questions, a high credibility score.
I thought you were going to say something completely different, like nobody reads anymore.
The thing is, though, it's been the case for a long time.
Yeah.
People, yeah. I don't think that a lot of people read either.
I mean, you said earlier, in one of your commented sections, you said, "Oh, I did put this here," and I thought, when you said that, I thought, yeah, I gain a lot of knowledge and experience from reading your commented sections, because sometimes it explains far more than what the code of the script does. And when you get to that level, when you're reading the entire script and the comments and the code, and it all comes together, and if people don't bother to do that, then they're missing out. There's so much education. I do actually spend a lot of time commenting my stuff, because I think if somebody's going to read this, they're not going to understand what's going on.
Yeah, standard professional thing to do. To be fair, I mean,
you're a programmer.
Yeah, it's a standard programming thing to do. Yeah, I mean, you should always comment the code. I mean, that's where I learned it from. Yeah, by looking at people's code, and they'd already commented it, so I did the same. It just seemed the thing to do. I didn't know why you did that. Like, it's not as if you needed to. You just wrote it and it worked, or it didn't. You made it work. But other people were commenting it, and yeah, it does. To me, I mean, I do it. I comment things because what does this say here? I mean, this kind of thing here is quite clear. I know exactly what this does, but this is just sort of basic standard that. Yeah, it's just nice to see what it does. So for this kind of comment, this doesn't work for a podcast, does it? But basically, I'm just looking at one of the scripts I've got in the source tree, and it's pretty, pointing out something that's pretty basic. But on the other hand, it's basic to me, but it wouldn't be basic to someone else, perhaps. So it is. These comments are for other people, but other ones are just for me. Sometimes,
Going back to what you were saying about forgetting things easy, you can then refer back to what you did, and if you've commented on it. It refreshes your memory.
Oh yeah, it does. Yeah, I mean, I've got I was looking more recently actually on the Slackware ARM website. You've got some of this, like it outputs what package it's building and things like that, which is actually coming from here. Here, this is like I'm just catting the local version of what you can find on the website on one of the build machines. What I've been working on lately is more actually just fixing some of the bugs in this in the entire build system, because I realized that Firefox would not build, and then I wouldn't catch the fact that it didn't build on the third pass. So this one only shows you there's only doing one pass here, because normally Slackware ARM has 3 build passes for every batch. So like I don't know if you're actually interested in this, but here it is. If you're not, just tell me and I'll close it. I have no idea if it's interesting or not.
Basically.
Yeah, so this is actually how it works. So the change log is actually so the Slackware ARM current, well, under 14.2, the change log actually contains the build list, because it might seem like a strange thing to do, but all of the comments eventually need to be in the change log, nowhere else. So I thought, why don't I just use the change log as the working build list as well? And that way I can merge any changes back in, directly into the change log, because they're all in here. So there's basically my build system comprises of loads of different sections or different call out systems, and then which is called R2B, the build system. And then it's basically I have a few different scripts. I take the x86-64 change log. So like here you see this here is the you can see it's an x86 version of Firefox with all of the comments, and so that's actually taken from the change log from the x86, and I dump it in here, and then my build system goes and takes any packages it finds between these two markers. It obviously excludes all of it only finds the packages, and it finds out what the option is here, like what does it need to do with it, and then it goes and builds them. And then it's got these markers here for CL, which means these are completed packages, and this is the stuff that goes into changelog. So then the script that makes the changelog reads this here. Well, actually no, it doesn't. It finds out what's most recent in the Slackware ARM tree, finds all the packages, and then it looks for the package name in this section of changelog here. So this is the x86 changelog. And then it just looks for the ARM package and then finds if there's any changelog information for the x86 version. So it just is, like regular expression matching and stuff like that. And then it assembles the changelog out of everything in here. And then you get the one that you get public below, this one here, the stuff that's public. So that's how it works. And then this one up here is to do. So actually, do what? Shall I show you? Are you interested, or you don't have to say yes. You just can say no.
I'm interested. I like this kind of stuff.
All right, so if I log into this one, and yes, I actually do use Telnet. It's because it's a secure LAN. I don't need to worry about SSH. And in the old days, the ARM machines were so slow that SSH actually made a visible impact to my life. So I had to divert to Telnet because it was faster without doing the encryption and stuff. So if I look at this, so this is just this machine that I've logged into is just it's the other Orange Pi, which is my other current build machine that I have running, which is also on my desktop, which I do the tests on. So basically what am I to do? So there's these two here. So I've got these 4 packages: kernel, firmware, sys5, init, bind, and then that. I have not actually looked at what constitutes the change. Right. So for example, what I do, I've got this package tool, this build script tool, which is one of my build systems. And then someone, I don't know if it was you actually, Brent, maybe, no, can't have been you. Someone emailed me once saying, how do you keep up to date with the packaging stuff, like with the Slackware build system? Because, it's quite a bit changing. I was like, well, it wasn't automated, it was all manual, and now it's all automated. So what I do is I run this script first, and then inside, you can't see it on the public FTP side because it's not there. But there's a copy of the Slackware x86 build script inside of the ARM build script. So, and what this does is it compares what's in the Slackware 64 current tree, which I just download it like everyone else does, and then I compare this script compares what the difference is between the one I last had and the one that's current. So in this case, you see that nothing has changed. So I just run this in what's called peruse mode, so it doesn't make any changes. And so then here, I run it in peruse mode. It doesn't actually change anything. It just shows me what I would need to do or what it was going to do for me. and then and I do that because sometimes if there's a massive build script and it's like it's a load of changes, and I think, oh my god, it's going to take me ages to go and manually merge that in and test it and make sure I haven't got it wrong. So I just run it peruse mode first to make sure I'm not setting myself up for a bit of a long task that I don't have time for. But this one's basically there isn't really been much change there.
It's definitely very interesting, seeing how your workflow is.
Yeah, it's pretty automated now.
Best way to be.
Yeah, so I have like a script. It literally just does a diff between the local version of the Slackware private tree that's on this server. So there's nothing in there at the moment. It doesn't show me anything because Patrick hasn't uploaded anything different. But so that's what I do, and then I just run that script, and it just checks what the diff is, and that's why. And I just copy the lines manually at the moment, and then paste them into my changelog. That's why I had all the plus signs, because it was from diff. And I just download the updates with rsync. Rsync's the public FTP site or our public rsync server. Oh, lucky I did. Okay, this makes sense. So yeah, this is why I'm testing this. I thought I might have not done this. So I've copied the changes into the changelog to go, but I haven't actually downloaded the updates. So that's why my script didn't show a great deal. I was wondering why that was the case.
Right. Yeah,
so I just rsync from the public FTP site, which usually doesn't take too long because there's not that much changed actually. And then it touches it up from the private, from one of the Slackware servers where the non-public tree is, the pre-public tree is, in case I want to do any development on stuff before it goes public, which I don't normally do anymore. I used to do that actually, but I don't do it anymore. It's easier just to follow what's been made public than it is to follow Patrick's internal stuff.
Just out of curiosity, Stuart, what command options do you use for rsync?
Don't know. Probably -PAVV, I guess.
Yeah,
--delete.
Right. Yeah.
It's nothing special. Nothing. Probably the same as what's on the just --P-A probably, and VV because I've put lots of verbosity on it. This will be done in a moment because there's only a couple of changes, and I'll show you actually what it does. Might have to edit this bit out of the podcast.
Yeah.
Well, maybe, I don't know. Maybe. How long have we even been doing this for? Oh, wow. 1 hour 26. We've run out of beer as well.
Oh, that's bad.
I know. It was only one of these small ones. Have you ever had that thing, when you have like really small beers and then you drink them and then you don't realize, you think, oh, I've not had very much because they're small. But then in aggregate, you kind of like, you just sit there drinking for a while and then you kind of get up and then realize that actually they might have been stronger than you thought.
Your bin's full. Yeah.
Yeah, the bin's full or the floor is full. Yeah. I'm not at that stage, however. This is the first and only one of the day. Although quite amusingly, I had a video conference with one of my customers earlier, and he had a beer in front of him on the desk and he was drinking it. It's like, hello, new account manager. How are you? Are you doing better yet? Finish drinking is going to get better.
He'll be getting rebuked from these captures people like Piers Morgan did for drinking beer in the morning.
Did he?
Yeah, there's some news story I read the other day that he had a pint of beer at 9 o'clock in the morning or something. And
God, I can't think of anything worse.
Yeah, I know. The beer was fine. It's just Piers Morgan.
Just Piers Morgan.
Yeah.
If you don't know who Piers Morgan is, Brent, he's
obnoxious.
That's a nice description. Yeah. He's obnoxious.
Mm-hmm.
But deliberately obnoxious because he just that's what he does as his modus operandi. He just is like that.
He's a Jeremy Kyle of journalism.
Right. So
I know how that is.
Yeah.
I think he doesn't he have something in the US as well though?
Oh, he got fired from that.
Yeah, he got fired. I think isn't he on BBC or something now?
Oh, he's on ITV.
Yeah, he's on Good Morning Britain.
Commercial thing.
Oh. I
don't
get that.
Lucky you. You're not missing it. Do you know what? I was actually on one of those TV programs at one point talking about biscuits. It's true. So this is the Slackware updater tool that I've got for ARM. So basically it does, it looks at that little list in the changelog and then it just tells me so this gives more information than the previous one. And then it just tells me what the changes are, which you can see there aren't any. and then it tells me. So then it goes ahead and actually changes the version number in my in the ARM Slackware ARM tree to the one that's in x86-64. So I don't have to do anything, and it resets the build number to 1 and all that stuff. And it goes, look. Oh God, I've actually got some work to do here. Look, I've actually got to do something. Oh God. Okay.
Do you run this in a screen, Stuart?
In screen? What, in GNU? In screen, as in GNU screen?
Yeah.
No. I mean, I could, but no. I mean, this isn't supposed to take long. I mean, like, so for example, on it actually, given that you're actually here, I'll just do it because
Qemu is still running.
I'm wondering, because you do a lot of exporting. I only usually do that in a screen.
Exporting? What do you mean?
Yeah, exporting vars.
Where's it? No. Oh, no. That's not what's going on there. That's the I know. Okay, what you're referring to is, I'll show you what you're referring to in a sec. What is this here? So my script has detected that the sys5init script needs an update. The Slack build script. What you were looking at, Phil, was actually this. So this is export. This is the ARM/build script in the source tree. So this sets the oh, that's old. I'll get rid of that. That's ancient stuff. Here, look, it's really old cruft in the build script from the archaic days.
And now it all crashes.
That's not needed. That's for my hacking system. Long gone. No, what you're looking at there is doing a diff. So basically, it copies what the subscript does. Is it copies for example, the source/a/sys5init. It copies it, and then it does it makes a change. It updates the version number and whatever, and then it does a diff between the one that it copied and the one that's now in the tree, and shows me, so I can review it to make sure it hasn't gone crazy. So it's actually just showing you the output, the diff of 2 script files that are in the source tree. Okay. It's not doing anything else. So for example, I'll show you. So for example, I just have to go. So my script is showing me the difference between the latest version of the sys5init script and the one that I've got in Slackware ARM. So what I need to actually do is just manually merge this in. And this is actually why it does take a little bit of work, but not much, nor ordinarily, because most of these build scripts they don't need to change very much. But like, oops, whoop. But that's basically it. This is the other reason why. One of the other reasons why I have my own build scripts is because I like the way that I do things. Sometimes differently to the way Patrick does them. So I like having that control of my own stuff there. This is usually easier for me. I actually have different windows open on my actual Linux desktop where I can just easily paste it in. It's actually usually easier than this.
Yeah.
But in the back of my mind, I'm wondering. Oh my God. Oh, okay. So this is an example of a Stuart modified script. So as you can see, this people on the podcast can't. But hang on, am I actually doing something wrong? Hold on a minute. Yeah, so this is like where I've completely changed the way that the Slackware script is. Because I do edit certain things of the script, like the way that Patrick does certain things, I don't like certain things. I prefer to use other commands to do them because I just prefer it. So that's one of the things that I like to do for myself. It's a bit of extra work to do it this way, but I have thought a number of times actually whether I should just ditch what I've done and just use the x86 build system, the scripts, and just pick up after them and then put things in the right place. But I spent too much time doing it the other way around, and I prefer having my own scripts really. There we go, that's done. So there we go, and then so I've merged a couple of changes in, and then that's it. There we go. So you can see what it's changed. So I can review what I've done. So you saw I deleted this old archaic junk. There's some really old stuff from like 2003 or something in there. Doesn't need anymore. And then there you go. And you can see the differences in the scripts that I've made in the build scripts, the ARM build scripts. And then it moves on to the next one. So there's bind. In this case, the bind build script in Slackware hasn't changed. There's no output from the diff. And then it shows me that my tool has updated the version for me. So I don't really have to do anything. So then it just tells me, for example, it's got loads of error checking in there and testing and stuff. So it tells me that the ARM binary package is missing for the XF86 video Intel package. That's because that doesn't build on ARM. But it's found that it's missing. So it's telling me as a warning. And then it's telling me that one of the packages in this batch, I assume it's sys5. Yeah, it's definitely sys5init in this batch. Yeah. Is inside of the mini root that I ship. So it's going to build the mini root build script as well. Oh, sorry, it's going to run the mini root build script and build the new mini root. And then what it does is it updates the build script. It updates the change log, so that now it's made these two markers here. It's put them in between R2B markers, which tells my R2B script, which is another one that's currently building the system.
Hey, Brent.
Yeah.
Doesn't the speed at which Stuart works make you feeling dizzy?
Yeah.
Honestly.
Is it?
I mean, I move pretty quick with my Slack builds, but that's because they're just Slack build scripts. I don't use a build system. I just,
I work with scripts. I always work with scripts, and some of the time when Stuart's doing things, he's just trying to keep up with him. It's amazing.
Well, I mean, it makes sense what he's doing.
It
increases efficiency. So.
Oh, it's a good system. I mean, have you seen the Beehive glimpse on the Slackware ARM site?
No.
No, you should take a look at that. It's I'm jealous of that. I would love something like that for SARPy. Really would.
Make one.
Yeah.
So there it is, right? I've just deleted that x86 thing because I know that isn't going to work. And then it's put this little at the top of the build system, the batch here. So this is basically a batch. So basically, I'm just showing what's like it's a Slackware update batch. Here's the latest, here's the days, and here's the things that changed. So here's the build script batch, and then at the top it's got this call out to build the mini routes, and then it runs that build script that's on the FTP site to go and build the latest mini routes. So I don't have to really do anything. And then I'm not actually going to run the build on here because this is an older build machine. It doesn't have the latest version of current on it. It's my kind of get me out of jail machine in case I break everything, which to be fair never really happens anymore, but just in case. So yeah, and it's old. It doesn't have the latest stuff, so I can't run it on there. But yeah, that's how it works. That's how it works. It's literally a change. It's a to-do list and the change log, and then and then on the other one, where's the other one gone? Oh, there it is. Zippy, yeah, there's Zippy, and then so Zippy's busy building stuff under screen. So it's building Firefox, and it has been for quite a long time actually, because it really does take ages. And and then that's what it does. And then so this is what you see on the ARM Slackware website, which is it just tells you how long the package has been building for and stuff like that. So it's been building for 31 hours, my Firefox, and it hasn't finished yet. And then after that, it will build Sea Monkey. That's next in the list.
Does that one take longer than Firefox?
No, I think it's shorter. Not sure, but I think it's shorter. And it's not as big as Firefox. I don't think it just doesn't take as long. Yeah. Unfortunately, though, the Firefox actually doesn't build with distcc. It does to begin with, but then it breaks, and then so I've in my build system it unsets distcc and tries rebuilding it without it, and then it works. So it gets some way there, and then it kind of fails. I haven't looked into why it does that, but sometimes it's just not worth it. It's just worth hacking it, making it work, and then just walking away for a few days and coming back. But yeah, but that's it. I can't show you how to build that, but well, actually, I could do. Yeah, I could do. Actually, look, if I change. Oh no, I can't because. Oh yes, I could. Yeah. Oh, that really isn't going to work for the podcast, is it? I can't even remember the command how to use the damn thing. What? Oh, there we go. Yeah. So you put like so I run my R2B command, and then So So ordinarily it takes the changelog from the current tree, but I can just give it an option to point to a different changelog, so it doesn't interfere with the one that's running on the main build. There we go. And then what it does, so basically it passes the list that's in the batch, and it tells you, like for example here it says to run the kernel firmware only on the final pass. It's got like a little token prefix on that package. Cool. And then it checks whether the x86 file name matches the ARM file name. Make sure it's got the right scripts are in place and it's got a version match and all that stuff. And then then it launches the build script. It sets the system time with NTP because it tends to go a bit wonky after a while. And then goes ahead and builds it. And then it goes installs it, upgrades it, and then moves into the next one. And then it does it 3 times. It goes over the list 3 times unless I tell it not to, or tell it to use a different number of passes. It's quite good. That's how it works. So that's taken like about 20 almost no, probably about 18 years to get to the point where I don't have to do very much anymore and just, just leave it, just could have maintain it.
That's the beauty of automation. I mean, automation, it's the same every time. Nothing goes wrong. And like you say, you can walk away and just leave it for days if you need to.
I wouldn't say nothing goes wrong. That's definitely not the case.
When it goes wrong, it really goes wrong with automation.
With updates and changes, you've got to dive in there and manually fix it. But for the building of it and for the process it uses in order to build, it's the same every time. That's the beauty of automation.
Yeah, you've got the consistency there.
Yeah.
All right, guys. I'm going to kill that off actually, but then I'll just take when it's done. I'll actually just I'll just run this. I'll process the same batch on the other machine on the new one. But right, guys. Well, I'm going to have to leave you there because I need to go and put the kids to bed and stuff. One of them just came out to the garden and stared through the window into my office. But it's been really good to talk to you guys. I'm glad we've got the QEMU stuff working.
Okay. Yeah.
And we can speak again if you like. We can do another podcast at some point.
Sure.
All right. Thanks a lot for joining us, Brent. And that's goodbye from me.
Thanks for having me.
You're welcome.
And it's goodbye from me.